We're going to be looking at how to solve and graph inequalities that are one-step and two-step. But first, let's talk about what an inequality is. So when you have a mathematical sentence that contains a less than, greater than, less than or equal to, or greater than or equal to sign, it will be called an inequality. So it's not equal, it doesn't contain an equal sign, but it's less than or greater than, and we're going to compare these two sides of the inequality. So when you see this symbol here with the little side of it pointing to the left, that's read as is less than, or you could see it as is fewer than. Those are two different ways that you can say that symbol. Now, alternatively, with the little side facing to the right here, we have is more than or is greater than. Both of those are going to be the common way that you'll see that. So is greater than. Now, the other two symbols look the same, however they have that line underneath them. That's going to mean this is less than or equal to. It's one big statement there, less than or equal to. So that would mean that the sides of that, that certain inequality are going to be less than each other or equal to each other. The other way you could see that, it could say is no more than, or you could see is at most. So those are three different ways that you could say that symbol, or you could see these words and then that symbol would be used to represent whatever that sentence is mathematically. Now, just flipping that sign around, but still with that bar underneath, that would be is greater than most commonly here. Greater than or, is greater than or equal to. You could also see is no less than, or you could see is at least. So all of these would be different ways you could see this and then represent it with this symbol mathematically. So some examples, changing our sentences into inequalities. The first one says less than 50 students attended the game. So we could say S is the number of students we're talking about here, and that would be students. The number of students is less than, we'll use the less than symbol, and 50. So the actual number of students that attended the game was somewhere under 50, but we're using this variable to represent it because we're not sure. Now in the next one we have going to the movies will cost at least $15. So I'm going to say M is the cost of going to the movies. Since we don't know what that actually is, we just know that it'll cost at least $15. So when it's at least $15, M is going to be greater than or equal to 15. Because at least it could be $15, but it could be more than $15 as well. So that's why we use this greater than or equal to symbol there. So just make sure you're reading carefully, looking for those keywords that we just wrote up top on our notes. So we had less than and at least in these two examples. So now that we've kind of familiarized ourselves with that, there is a certain way that we need to graph inequalities, which you might have seen before. In this first one, we have x is greater than 3. So we have a greater than symbol here. There's no or equal to line with this. So that's going to tell us that we'll be using an open circle. So I have this unfilled circle right up top in this key. And our x here is what we're going to be trying to show on our number line. That number is going to be greater than 3. So that means that any number that we put there needs to be higher than 3. So we're first going to look, okay, we're talking about the number of 3. I'm going to draw a circle over 3. We know it needs to be an unfilled circle because we don't have a line underneath this inequality. And then x needs to be greater than 3, so we're going to shade all the numbers that are greater than 3. And I'm going to draw an arrow showing that we could keep going. Any number past this to the right is going to work here. Now, another way you could think about this is whichever side of your inequality sign is touching the variable, we're going to shade either to the little numbers or the greater numbers. So right now, the bigger side of our inequality symbol is facing our variable. So if we label our numbers over here, these are our numbers that are from least to greatest on our number line, but this is our greater side of our inequality, so it's greater. That means we would be shading to the G, and that matches what we did the first time. So let's try that technique over here. We're going to label our numbers least to greatest again, so L to G. And this time we have -4 is greater than or equal to x. So a few things we need to look at here is we have the greater than or equal to symbol. That means we're going to be using a filled in circle this time. So we'll shade in the circle above that number. So that's the first thing we're going to do is put a filled circle above -4. And then this time when we look at our inequality sign, the little side of this inequality side is touching our variable, our x here. So that means we'll be shading to the lower numbers. So we shade to our L, and then if we test this out and say, okay, well, -5 is a number that would be shaded here. So if I put this into our inequality here as -5 is x, -4 is greater than or equal to -5. This is a true statement, so that L and G trick is a good trick to use for this type of graphing. Now, we just practiced graphing the inequalities, but sometimes you're going to see inequalities that don't have the variable all by themselves. You need to solve for it first and then graph it. So when you solve an inequality, it's going to be the same way that we learned how to solve an equation. So whatever you do on one side, you need to do the other. And then there will be a few other rules that we'll talk about later in the notes for these. So in this example, I have 9 is greater than 3x. So I need to get x by itself here before I can graph my inequality. So we have to think about, okay, well, what's happening to our x? In this case, 3 is being multiplied by x, so we do the opposite, which is dividing by 3. And just like in an equation, whatever you do on one side, you need to do the other. So we're going to divide by 3 on both sides. 9 divided by 3 is 3. This inequality sign is going to come down, and then 3x divided by 3 is just going to get us x. So now we have 3 is greater than x that we need to graph on our number line. And in this case, the little side of our inequality sign is touching our variable. So that means we'll be graphing to the L. So if I label my numbers from least to greatest, we're going to be graphing towards the L this time. Now the number that we're talking about is a 3, and we're going to need an open circle on 3 because we don't have an or equal to part of our inequality. And I'm graphing towards my L, which means I'm shading to the left, and I'm going to include the arrow down at the end. So if you check this, if you plugged in, say, -2 for x, you would have 3 is greater than -2, and we know that that's a true statement, so we're good. So it's a good way to check to make sure that you shaded to the correct direction before you move on to your next problem. Now we can go to our next example. We have 1/2 x is greater than or equal to 2. So we look and find our variable, it's on the left side here, and right now it's being multiplied by 1/2. Now remember, whenever you have a coefficient that's a fraction, we just have to multiply by the reciprocal. So we're going to multiply by 2/1 on both sides here. When we do this, this just becomes x is greater than 2 times 2 is 4. 4 divided by 1 would be 4. So that gets us x is greater than or equal to 4. Now this time, our greater side of our inequality is touching our variable, so this is the big side. So that means we're going to be shading towards the bigger numbers, or G. So from least to greatest, we're going to be shading towards the G, the bigger side here. So the number that we're on is 4 this time, and we need a closed circle because we had an or equal to type of inequality symbol. And we're shading towards the G. And if we want to go ahead and check, we could put a 5 in for x here. So if we plug in 5 is greater than or equal to 4, that is true. 5 is greater than 4, so that's a true statement. We're good to go. Now we have some two-step inequalities. At least in this next example here, we have 2x plus 5 is less than or equal to 9. So remember, when you're dealing with a two-step equation, we always looked for the constant first. It's going to mean the same thing here. We need to get rid of the constant from the side with our variable first. So 2x plus 5, the opposite of plus 5 is -5. So I do that on both sides of my equation, or my inequality. 2x comes down, and our 5 minus 5 goes away. The inequality symbol comes down, and 9 minus 5 is 4. Now we just have to treat this like a one-step inequality. We have 2x is less than or equal to 4. Right now 2 is being multiplied by x, so we're going to do the opposite and divide by 2 on both sides. When we do that, we're left with x is less than or equal to 2. So now we need to put a closed circle on 2 because we have less than or equal to. I'm going to put my L and my G to decide which way I need to shade. And the little side here is facing our variable. So we'll be shading towards the L this time. I'm just going to fill in that whole side. And if we go ahead and check any of these numbers, I'm going to use 0 here. 0 less than or equal to 2. Yes, that's true. 0 is less than 2. So this is a true statement and we shaded correctly. You should go ahead and try number 4 on your own. You can pause the video and then check when you're done. All right, now that you've tried it, you can check your work. We have x plus 7 over here, and to get our variable alone, we need to do the opposite of what's happening. So instead of adding 7, we're going to subtract 7. And remember, whatever you do one side, we got to do on the other. So we have 12 minus 7 is 5. Our less than sign comes down. And this plus 7 minus 7 is going to be gone, so we just have x over here. So I have 5 is less than x. So we have the big side of our inequality sign touching our variable this time. I label my L and my G. I'm going to need an open circle on 5. And since we're touching the big side of our variable here, we need to shade towards the G, the greater number. So we'll be shading to the right. Now if we check to make sure that looks good, a number that would be to the right of 5 would be 6. So if I plug in a 6 where x is, 5 is less than 6. Yep, that's true. So we did it correctly. Now, something to note when you're solving these inequalities, like we were just looking at, solving the inequalities is going to be the same as when we solve equations because you have to undo the operation that's given to you. So in that last one, we had plus 7, so we subtracted 7 to undo that. But there's one difference that you need to remember. When you multiply or divide the side with the variable by a negative number, you must flip the inequality sign. So fill in that rule and then we'll do a few examples to show you what that means. So in this first example, we have negative 5c is greater than or equal to 25. So it looks like a normal inequality. You need to just solve it. Right now we're multiplying c by negative 5. So to undo that, we would have to divide by negative 5. I'm going to do that on both sides. When I divide by negative 5 over here, I'm left with c. And when I divide by negative 5 on this side, I'm left with negative 5. But I'm going to think about what's that rule I just talked about. I'm dividing this side with the variable by a negative number. That means I'm going to take this inequality sign that right now says greater than or equal to, and I'm going to face it the other way, which now means I have c is less than or equal to negative 5. So I had to flip because of that dividing by a negative 5 there. So we divided by a negative, we flip the sign. Now we have to graph this. So first thing we want to do is find negative 5. That's going to need a closed circle because we have a less than or equal to sign here. So we close it. I'm going to put my L and my G here, and then we're going to decide which way to shade. The little side of our inequality sign is touching the variable, so I'm going to shade towards my L, and there's my graph. So now if we check this, we can even start back with our regular inequality that we started with. So I had negative 5, c is greater than or equal to 25. Now I shaded it over to the left, so I'm just going to pick a number that I shaded above. Like let's say if we use negative 8 here. I do negative 5 times negative 8 should be greater than or equal to 25. A negative times a negative is a positive, and 5 times 8 is 40. So that gets me 40 is greater than or equal to 25. That's true, so we know we shaded to the correct direction, and we solved this inequality correctly. Now let's try the next one. We have x is being divided by negative 2, less than or equal to negative 2. So right now x is being divided by a negative 2. We're going to do the opposite and multiply by negative 2 on both sides. When we do this, our negatives are going to, our multiplying and dividing are going to cancel each other out, so we're just left with x. Negative 2 times negative 2 is 4. But over here, we did have to multiply this side with the variable by a negative number. that's going to mean we need to flip our inequality sign. So instead of it saying less than or equal to, we're going to change it to say greater than or equal to. So now we need to go above our 4 and put a closed circle because we have greater than or equal to. I'm going to label my L and my G from least to greatest. And this time the big side of our inequality symbol is touching our variable. So I'll be shading towards the G for our greater numbers. And then let's go ahead and test this. So if I plug in a 5 here, I have my original inequality was x divided by negative 2 will be less than or equal to negative 2. If I plug in 5 here, I have 5 divided by negative 2 is less than or equal to negative 2. And when I do my division here, that's going to get me negative 2.5 is less than or equal to negative 2, and negative 2.5 is less than negative 2. So that is a true inequality there. We graphed to the correct direction, and we solved our inequality correctly. Now in our next example, we have x divided by 3 plus 2 is less than or equal to negative 1. So this is a two-step inequality that we need to get rid of the constant first. Right now we're adding 2, so we're going to subtract 2 to undo that. When that happens, our constants go away on this side, and we're just left with x divided by 3 is less than or equal to negative 3. All we did here was subtract. That does not change the sign of our variable. Now I have x divided by 3 is less than or equal to negative 3. So to undo this division by 3, I'm going to multiply by 3 on both sides. When I multiply by 3 over here, I'm left with x. On this side, I have negative 3 times 3 is 9. Now I am multiplying by a negative on this side, but the side that I multiplied with on my variable, this was a positive number that I multiplied by. So our sign will not flip here. It's still going to be x is less than or equal to 9 here. So let's graph this. We're going to put our L and our G. We need, I'm sorry, this should have been a negative 9. Negative times positive is a negative. So we need to put a closed circle on negative 9 here because we have less than or equal to. And the little side of our inequality is touching our variable. So we're going to shade to the L. And let's go ahead and test to make sure we did this correctly. So a number that would be to the left of negative 9 could have been, let's say, negative 12. And we'll use that as our test example. So if I put negative 12 divided by 3 plus 2 should be less than or equal to negative 1 here. Negative 12 divided by 3 gets us negative 4 plus 2. Negative 4 plus 2 gets us negative 2. And that is less than or equal to negative 1. It's less than negative 1, so that is true. So we solved and graphed that correctly. Now in our last example, we have one more two-step equation here. First thing we need to do is get rid of our constant on the side with the variable, so I'm going to add 1 to both sides. That leaves me with 6z is greater than or equal to negative 36. Now I'm multiplying z by 6, so I'm going to do the opposite and divide by 6. When I do that, I'm left with z, and then over here I have negative 6. Now, again, we are dividing using a negative number here, but it wasn't on the side with the variable, so this will not flip their sign, and now we're just left with z is greater than or equal to negative 6. So we have negative 6 here. We're going to need a closed circle on it because we have that line underneath our inequality sign. We need our L and our G, and we have the big side of our inequality sign touching our variable, so we're going to be shading towards the G, towards the numbers that are bigger. And then let's go ahead and test one of these out. So our original equation was 6z minus 1 is greater than or equal to negative 37. And a number that we shaded in was negative 1 here. So let's do 6 times negative 1 minus 1 should be greater than or equal to negative 37. 6 times negative 1 is negative 6, minus 1 is going to get us negative 7. And negative 7 is greater than negative 36. It does fall to the right of negative 36 if you put them both on a number line, so that number will be bigger. And this is a true inequality graphed correctly. So just make sure that you're following the rules for when you're dividing or multiplying by a negative on the side with a variable, that you're flipping your inequality, and use the L and the G trick to help you graph these inequalities correctly, always go back and check your work. You'll know you got an A before you even turn in your paper. Thanks for watching.